What's going on, guys? It's Mr. Jones, your math teacher. I just wanted to do a lesson for you guys today, a review lesson, hopefully, on arithmetic sequences and or linear equations. Those two things are very similar enough for this class. We'll just consider them the same thing. So think about all the things you've learned, hopefully, last year in regards to arithmetic sequences and or linear equations. If you look on the top of the screen, it says table, graph, explicit equation, recursive equation. Right up here, if I can find my mouse, there we go. Think about doing those things today and how you've done those in the past, because we're going to be looking for those things today. So on that note, get your composition book out if you haven't already done that. Pause the video if you need to. All right, the first thing I want you to notice is the dots that you see in the middle of the screen. So that's a sequence. You can see at the beginning, at 1 minute, at 2 minutes, you see dots, more dots. You see them growing in a certain way. So the very first question is, describe the pattern that you see in the sequence of figures above. So basically, I want you to talk about how you see it growing. How do you see it growing? And what I want you to do also is in your composition book, draw these dots. Draw this entire picture, if you will, in your composition book. And then describe how you see them growing. All right, hopefully you had a chance to write some nice sentences for me. A lot of students see a lot of different things here. It's not really what's important. Some students, for example, see 4 legs growing with like a middle, so they kind of see it like a table or like a spider with only 4 legs or whatever. So it just depends. Some students see boxes, so maybe you saw it growing by boxes. It just really depends on you. So whatever you wrote, I'm sure is completely fine. The next question, and I also want you to draw this in your composition book, is assuming the pattern continues in the same way, how many dots are there at 3 minutes? So go ahead and think about this. At this point, if you want to make a table, that'd be cool. We're going to make one anyways. But go ahead and draw the dots on your paper showing what they would look like in 3 minutes. Go ahead and pause the video so you have time to do that. All right, now on my screen, hopefully you can see that I drew it as best that I could with this little program. And you can see that it probably looks a little bit less beautiful than yours. So hopefully you got the answer of 13. And if you did, it should be in your composition book. All right, so now for the harder question. How many dots are there at 100 minutes? I want you to use whatever strategy you can think of, and you're going to have to explain in sentences how you got what you got. So think about what you can do to figure out how many there will be at 100 minutes. All right, hopefully you got the answer of 401. Many students make the mistake and get the answer of 400. So if you did, no worries. But I can tell you probably forgot that you have to add the 1 extra from the very, very beginning, the dot that was already there at the very beginning. So good job to everybody regardless. If you didn't get it right, maybe you learned something. To give one strategy that students will use, if you think about this as being legs, kind of how I talked about before. So let me draw some on my figures. So assume that, there was already the 1 in the middle, and then there's these legs that grow out of it. So the number of legs is corresponding with the number of minutes. Not the number of legs, the number of dots in the legs. So for example, each leg has 3 dots, or each leg has 2 dots. Over here, each leg has 1 dot. So if you think about it, at 100 minutes, how many dots would there be per leg? there'd be 100 dots per leg. And how many legs are there? 4. So just like up here where you can say 3 times 4 and you get 12, you have to remember to always add the 1 in the middle, and that's how you got 13. So whenever you do the 100 minutes, 4 times 100 is 400, but don't forget to add the 1 in the middle. So now what we want to do with the problem is I want you guys to make a table. I want you to make equations and a graph if you can. But basically draw a table and do all these things before I give you all the answers. That's how we learn, and that's how you spark your memory. And you're going to feel better about yourself if you do it that way. But in your table, tell me what x represents, tell me what y represents, and also show me the explicit equation. Remember, that's the one that you can plug in any value of x and you get a y value. And then also, if you can come up with the recursive equation, go ahead and do that as well. All right, so now that you've had a chance to do all that, here is the table I've made so far. You can see that x is the number of minutes and y is the number of dots. So on the x side, I started off with 0. That was the at the beginning. That's whenever 0 minutes have passed. And then at 1 minute, 2 minutes, 3 minutes, 4 minutes, and I stopped there. Obviously, the table goes on forever, but I'm not drawing a whole bunch of numbers. So here we go. At 0 minutes, we know we had 1 dot. We know we had 5 dots. We know we had 9 dots and 13 dots. And we knew that the pattern was that we are adding 4 every single time, right? So this difference right here, this 4 is called our common difference. Common difference. And another name for this is actually going to be our slope. Whoop, pressed a button on accident there. Slope. Oh my goodness gracious. Let's try that again here. Let's just back out of that. And we'll do this. Oh no. All right, slope. Sorry, I'm still learning this crazy pen. All right, so that's going to be our slope. So whenever you think about adding 4 every single time, we're really thinking recursively. So if you guys remember that the recursive equation is basically saying, hey, what comes next? So we should be able to figure out what comes next by just adding 4. So 13 plus 4 is 17, right? 17, that's automatically the next number. For those of you guys who came up with the recursive equation, here it is. F of x, remember, means the term we're looking for, and this means the term that comes before it. So the term that we're looking for, the 4th term, is equal to the term that comes before it plus 4. And so this is considered our recursive equation. If you guys didn't get that, it's okay, but if you did, kudos. All right, and the one that we like the most is the form that you guys are most familiar with. This is where linear comes in, y equals mx plus b. We know if we're adding the same number every time, that's what makes it arithmetic. That's what makes it linear, is that we have a common difference. We're adding the same number every time, and then we can automatically put it in the form y equals mx plus b. And if you guys didn't come up with the equation, or you did, here is the equation. Y equals 4x plus 1. 4 represents your common difference or your slope. That's what your m value is. And your b value is your y-intercept. That's your starting point. So earlier, whenever we did the 100, we said 4 times 100. And then we had to add the 1. And that's how you can kind of justify your equation from the picture. Okay, from the picture. And one more thing to remember, in this equation, the explicit, this is explicit, right? This equation is explicit. Same thing as y equals mx plus b. Those are the explicit, that's the explicit form. This is the explicit equation. Okay. This value right here is always your common difference. And this value right here is always your y-intercept. Okay? All right, and that sums up this problem. Hopefully you guys got your memory sparked a little bit. If some of this was new to you and you're still confused, please let me know. Either email me or talk to me during office hours and Zoom or whatever. But please ask, okay? This is stuff that we should know. The main thing is that you guys become familiar again with patterns and also how to make tables and equations and the strategies that you use to do those. All right, talk to you guys next time.